I'm Now.
Hello, I'm Chris.
And I'm Shaurya.
And I'm Joanna.
We are from TrafficGPT Mobility Solutions. Today we're going to propose some solutions to a problem everyone has faced every day: traffic congestion. All this honking is so irritating, yeah?
Yes, it's really annoying.
Now, like any of us, like all of us over here anyways, how many of you get easily irritated by all of this honking? It's no doubt that everyone can easily get irritated by honking all the time, anytime. Now, let's move on to another example, Barsha traffic. If you go through Al Barsha from 4 p.m. onwards, you will see that all the crossroads will be filled. No one dares to move into the junction because all of the crossroads are filled and everyone will have to start paying fines. So, we present our solution, TrafficGPT.
First, let's start with some key facts. 3.5 million vehicles are present on Dubai's road every single day, and in a city with 4 million people, the traffic ratio is deeply concerning, especially when you start to think that the growth rate of Dubai is 6.13% every year.
And those vehicles release 14 tons of carbon dioxide every year, which combined weight of 140 ships. And not just that, due time loss in traffic, especially Dubai, a lot of resources too get wasted.
In 2013, 3 billion dirhams worth of resources were lost due to traffic. Today, the numbers are significantly higher.
Let's take another example. Our school roundabout. Sometimes it takes half an hour to travel just 500 meters. Why don't I just walk?
Basically, we can go on and on about traffic, but long story short, it breaks the lives of everyone here. Now, moving on to our solutions, we have two: our website, Car Connect, and our model over here, TrafficGPT. Our model over here consists of an Arduino board which uses its own AI model coded by us and a multitude of mathematical concepts.
Let's now break down the math concepts powering our project. Linear algebra helps us represent traffic flow using matrices. Each row of the matrix represents the number of cars in a particular lane. And using matrix operations, we can find the future flow and identify the overloaded lanes. Ratio helps us compare vehicle loads. If road A has 200 cars and road B has 80, the ratio is 200:80, which is equals to 5:2. This tells us road A carries 2.5 times more load than road B.
AI uses statistics and probability to study and predict traffic patterns. It collects real-time digital sensors to predict traffic flow and find busy areas. By looking at past data, it can forecast congestion and suggest better routes.
This is the Poisson distribution formula. Here, X is the number of successes, lambda is the rate of successes, and E is Euler's number, which is approximately 2.71828. Using this formula, our model is able to predict congestion well in advance, which makes it extraordinarily capable. Moving on, we have calculus. We use integrals and derivatives to estimate the total traffic volume as well as derivatives to look at the change in traffic. For example, if we integrate t1 to t2 for f of t, we will find the total number of cars. But if we derivate the total number of cars, we will get the rate of change, that is f of t. Traffic changes very rapidly, and for any model to be efficient and practical, it is important that it is able to understand and comprehend that change effectively. Calculus is the key to that puzzle, as it helps us understand and solve this change.
Now, we have graph theory. In mathematics and in computer science, graphs are used to model pairwise relations between two different objects. Over here, a graph is made up of nodes connected by lines called arcs. Our school roundabout model over here is the perfect cyclic graph to demonstrate a dynamic routing changing. We have also implemented Dijkstra's algorithm. This Dijkstra's algorithm is a path-finding algorithm that helps our AI model find the shortest path there is.
Moving on, we have queuing theory. Traffic jams work a lot like queues. So, if we take X as the rate of arrivals and Y as the rate of departures in this formula, we find that if X gets approximately close to Y, the traffic explodes, meaning that no one is able to get to their destination effectively and quickly.
Now, we have a very important topic, LCM, which is lowest common multiple. We have used LCM over here to coordinate our traffic signals so they can coordinate each other while going simultaneously. For example, a signal has a cycle of 40 seconds and another one has a cycle of 50 seconds. The LCM of those two signals will be 200 seconds. This means that every 200 seconds, these signals will go green, releasing traffic as they go. Now, as I said earlier, Dijkstra's algorithm gives priority to the headlight having the most dense amount of traffic.
Finally, we have coordinate geometry. René Descartes revolutionized the medieval world when it came to the invention of the Cartesian plane, and it does the same for our model too. Coordinate geometry, and more specifically, the Cartesian plane, is used everywhere. Every single technology that we use today incorporates coordinate geometry. It's used in traffic engineering, smart city planning, road design, as well as congestion control. It is also useful to find the shortest path using the distance formula, which is useful to reduce travel time, among many other things. Finally, we have geometric curves. Highways, ramps, and flyovers use geometric curves such as parabolas, circles, and arcs to to ensure a smooth turning radius. Let's take another example: GPS technology. GPS technology plots your location on a Cartesian plane, which lets it understand your location in real time. And our model too does the same thing. By putting the points on a Cartesian plane, it is able to understand the structure of the cars and as well as the structure of the roundabout, which makes it capable. Now we have the UAE's contributions. The UAE has never been a country that steps back when it comes to new technologies. So, as part of its contributions to solve the issue that is traffic, it has taken many steps like the Etihad Rail, Dubai Hyperloop, as well as autonomous taxis. With these initiatives, the UAE government is making sure the traffic does not plague the development of the nation's economy.
Now, Joan, can you explain what problem our model focuses on?
Our model targets the school run bus traffic specifically. We started thinking about what really causes traffic.
We came to the conclusion that one of the biggest causes are people don't carpool. We all have same destination and we all come separate cars.
Think about it. 90% of the traffic in the roundabout comes from either Winchester or DPS, and both the schools are located right next to each other. So why not carpool? Imagine how many resources could be saved if people just started carpooling.
Now, let's take a hypothetical solution. Let's take a reduction percentage of 30%, and let's take there are 20 to 30 cars in each lane. Then there will be a total of 200 cars. Now, factoring in the reduction percentage to the total amount of cars, you will realize that we're reducing traffic by 60 cars. Factoring in their size, the emissions, and all the noise that they make, this is a very significant impact.
Which is why we developed a website that promotes smart, fast, and simple carpooling. We call it Car Connect.
So let's sign into Google here. And we use Firebase for sign-in authentication. So as you can see, we've signed in over here and it automatically shows a map of Dubai, which is your current location. Let's click on Create Ride. My name is Shaurya. And I'm going from DPS Dubai to say DPS Sharjah. And the date is today, I'm going today, and time is right now. And there are 2 seats that are available in my car, which I can share with someone. So I can click on Create Ride, and the ride has been created successfully. Now, if I scroll down, I'll see a card that shows me the route. If I click on Show Route, it will redirect me to Google Maps, where it shows the route automatically, and Google itself provides the fastest route based in real time. Let's now go back and take a look at Join Ride. Over here, you can see a list of available rides that we have created, and as well as a map on the right. Let's join this ride. You can see that the number of seats has been reduced since we just joined the ride. Now, it says join and it is going to be tracking live. So both the driver and the passenger can see where each of them are in real time.
Thank you, Shaurya, for putting light on our amazing solution. Now, I would like the judges to experience this firsthand by scanning the QR code.
Mathematics plus AI.
Equals smarter cities.
And with Car Connect,
Even students can make a difference. Now, moving on to a most efficient solution, our model TrafficGPT.
So let's break down the components that are powering our project. Firstly, we have LEDs, these ones. LEDs use binary code to light up. Could you please? LEDs use binary code to light up, and we're using them as signals over here. Next, we have the Arduino microcontroller board, which is right here. We use math here, specifically linear algebra and calculus. This is the hub for all of our operations. We have now sonar bits. These are ultrasonic sensors. We have 3 of them, one for each road. This helps our model understand how traffic is there.
Now, let's take a deeper look at our model.
Let's take a look at what are the functions of our model. As you can see over here, this is the school roundabout, which is just outside our school DPS Dubai. And these are all the individual roads which have ultrasonic sensors attached to them. And this is the final road. Now, allow me to elaborate on what is going to happen. Say that there is more traffic in one road, then the ultrasonic sensors will detect that there is more traffic on that road, and then they will look and calculate a score using the math methods that we discussed earlier. After that, the AI model will then make a decision on which road has to be green flagged. As you can see here, since there is more traffic on this road, the signal is green for road 2. Also, this solution is not just efficient, it's also extremely practical. In a lot of places, camera modules and advanced technology is not possible, especially in rural or third world countries. So, by using merely ultrasonic sensors and simple prototyping platforms like the Arduino Uno, we are able to build a working prototype of a wonderful solution. So, Nama, could you please elaborate on the key findings of our research?
Definitely, sure. Thank you. So our AI-based model over here not only makes travel more efficient, but it makes it more practical, as you said, because it not only reduces traffic jams by a lot of numbers, but it is the most efficient and you'll waste less time.
Not just that. A lot of the reason, a huge reason as to why there are a lot of crashes in places is because of excessive traffic. By building such a working solution, we are able to ensure safer roads for everyone.
Now this makes our future more and more efficient. Now you're no longer going to go late to meetings, go late to work, or miss any meetings due to our model.
We hope that you enjoyed our presentation.
Thank you.